Welcome to Computer and Network Security. Today I'm going to give you a brief overview of TLS, HTTPS, and SSH. So to start off with TLS, Transport Layer Security. This was originally an IETF, the Internet Engineering Task Force Standardization Initiative, whose goal was to produce an Internet version, standard version of SSL. TLS is defined in RFC 5246, and that's very similar to SSL version 3. However, there are some differences, like the version number. The TLS record format's the same as that of the SSL record format. The fields in the header have the same meanings. However, the version is going to be different. For the current version of TLS, the major version is 3 and the minor version is also 3, whereas with SSL, the major version is 3 with the minor version being 0. The message authentication code. TLS uses the HMAC algorithm that's defined in RFC 2104, and SSL does not utilize that. Okay, a few more of the subtle differences for the cipher suites. Utilizing key exchange, TLS supports all of the same key exchanges that SSL had, which was RSA and Diffie-Hellman, a couple versions of Diffie-Hellman. However, SSL also supported Fortessa, whereas TLS does not. The same idea with the symmetric encryption algorithms. So, as you see, it's just a few small, subtle differences. There's nothing that is that drastically different between TLS and SSL. So, because of that, most of the time SSL is used. However, we could use TLS in its place. SSL already had gained substantial popularity by the time that TLS came out, and so there weren't very many instances of utilizing TLS, although there are still some that could use it, and it does work in a very similar fashion to SSL. Okay, moving on to HTTPS. This is just HTTP over SSL. It's a secure HTTP. Refers to the combination of utilizing HTTP and SSL to implement secure communication between a web browser and a web server. This capability is built into all modern web browsers. Whenever you are transmitting passwords, bank account information, social security numbers, anything that has personally identifiable information or things that need to be kept secret, you should always make sure that the website is utilizing HTTPS and that it has a valid certificate for which it's using HTTPS. You should never enter this information just using HTTP. That means that anybody who happens to be sniffing the network would be able to get all of your information in plain text. If you utilize HTTPS, this is running at the application layer. You are going to be encrypting, if you look down at the bottom, the URL of the requested document, the contents of the document, the contents of the browser forms, cookies that are sent, and the contents of the HTTP header. So it is encrypting nearly everything that is in the HTTP message. When we utilize HTTPS, we're going to be operating over port 443 instead of port 80, which is the HTTP port. And that third bullet that I have there, make sure that you see HTTPS in the URL instead of just HTTP. Some browsers, such as Google Chrome and Firefox, may drop the protocol from the front. However, they have a little padlock right next to the URL if you're communicating over HTTPS instead of HTTP. The fifth bullet, you see it in RFC 2818, HTTP over TLS. There's nothing that's fundamentally different in that. So we could utilize HTTP over TLS. However, more popularly and typically it is HTTP over SSL that is used. Here's how the connection gets initiated. For HTTPS, the agent that acts as the HTTP client, which is the client, also acts as the TLS client or the SSL client. The client will initiate the connection to the server on the appropriate port and then sends the client hello to begin the handshake that we talked about in our SSL lecture. Once the handshake is finished, the client may then initiate the first HTTP request. However, when we're transmitting this data, we're transmitting it over SSL, or as this slide is showing, over TLS, and the data will all be encrypted, just as I explained on the previous slide. So there are 3 levels of awareness of a connection in HTTPS. At the HTTP level, the client requests a connection to the server by sending a connection request to the next lowest layer. Typically, this is going to be over TCP or UDP. It may also be TLS or SSL though. At the level of TLS, the session is established. Remember that in SSL and also in TLS, we have a session as being established. Since we're running in the OSI model, somewhere around layer 5, the session layer is where we're running SSL or TLS. We could have more than one connection at the same time inside of a session. And a TLS request to establish a connection begins with the establishment of the TCP connection between the entity on the client side and that on the server side. An HTTP client or server can indicate that a connection should be closed, sending a connection close in an HTTP record. This can also be done using an SSL alert. We saw that we can close connections using an SSL alert, which as a warning. The closure of the connection requires that the TLS or the SSL close the connection with the peer on the remote side. This is going to help out with not utilizing as many resources on both the client and the server if we are able to close the connection without having to wait for some kind of a timeout to occur for us to close it. TLS implementations must initiate an exchange of closure alerts before closing the connection, so that's where the alert comes into play. Otherwise, we're going to have an incomplete close, and this is where your timeout will occur, so that you will then be able to close the connection automatically without utilizing resources on your computer for an extended period of time. An unannounced TCP closure should be evidence of some sort of an attack, so the HTTPS client should issue some sort of a security warning when this occurs. We're communicating over HTTPS. We've already established this connection over the handshake, so there shouldn't be a problem with the server or the client having to send this close request. If for some reason no close request was sent, then it might be an indication of some kind of a problem or an attack, and that's why there should be some kind of a security warning if that happens. Okay, our third and final topic for today is SSH. The reason that I threw this into this lecture is because a lot of people confuse SSH for SSL and understand that they are completely different from each other. Obviously, they're both dealing with encryption still. However, SSH does not use SSL even. So they're very similar acronyms. However, they are not related to each other in anything other than the fact that they are both using encryption and that they're security algorithms. So that's the reason I threw this in here. Hopefully you don't get confused thinking that SSH and SSL are the same things. A lot of times you'll have people in companies, I've had a lot of people that I've worked with who like to use SSL and SSH interchangeably when in fact they are completely different from each other. So to explain SSH is a protocol that's used for secured network communication, designed to be relatively simple and inexpensive to implement. The initial version, which was SSH1, was focused on providing a secure remote login facility to replace Telnet and other remote login schemes that didn't have any security at all. So it's used as a remote login. You probably, if you've ever remotely logged into a server without using like remote desktop on Windows machines or something where you're actually looking at the desktop and controlling it, most likely you've used Telnet or SSH, which is much more popular. Many servers, including all of the servers that I host, I have Telnet turned off on all of them. SSH is the only protocol that I allow for logging in so that the data is completely encrypted between the computer that I'm using to log into the server and the server. So if anyone's sniffing packets along the way, everything is going to be encrypted between the client computer and the server that's using SSH. SSH also provides a more general client-server capability. It can be used for a lot of network functions such as file transfer and email. So we have a secure FTP that potentially could be using SSH as well for encrypting all of the data that's going back and forth over FTP email. Also, you can utilize SSH. We have talked about S-MIME, and that's another option for encrypting emails that are going back and forth too. With SSH2, there were a number of security flaws that have been fixed. It's documented in RFC 4250 and 4256, which are both RFCs from the Internet Engineering Task Force, IETF. SSH client and server applications are widely available for most operating systems. It typically is the choice for remote login. For X tunneling also, such as remote desktop, SSH could be used. And it's one of the primary forms of encryption that we use for transmitting data. Here is the protocol stack for SSH. So we have the user authentication protocol, authenticates the client side user to the server. The connection protocol multiplexes the encrypted tunnel into several logical channels. And then we have the SSH transport layer protocol, provides server authentication, confidentiality, and integrity. We've learned all three of those words already throughout this course. It may also optionally provide compression. It's built over TCP and IP, so you can see where it's running in the protocol stack. This is up at, SSH is typically at layers 6 or 7, the presentation layer, or the application layer. The encryption method that's used with the SSH transport layer protocol, there are two different trust models that can be used. One is that the client has the option of maintaining a local database that associates each host name, which is what's typed by the user, with a corresponding public host key. This is often the case for any of you who have used SSH to connect to a server where the server has generated that key itself, that the first time you connect, it's going to pop up a message that says, this key is being transmitted back to us in plain text. Are you sure that you trust this server? So you need to be careful with that. Oftentimes you want to do that from the same network where the server currently resides, so that you have less of a risk of a different server or a malicious computer sending you back a key where you think it's coming from the server, when in fact it's coming from some malicious third party that just happens to be sitting in the middle using something such as a man-in-the-middle attack. The other way to do it is if there is a trusted certification authority, a CA, then you can download a certificate directly from the CA, and then you would utilize that as well. This is going to be used in a number of SSH applications for remote login if a lot of the people who need to get those keys are going to be located remotely and can't come into the network to get the key originally. Okay, so hopefully that gives you a good overview of SSH. We briefly talked about TLS, which is very similar to SSL, and then HTTPS, which is just utilizing HTTP over SSL, typically is how this is done. So kind of a short lecture, but we have talked about three good technologies. Take a look at the textbooks. There's a lot of good information in those and a lot of good references online. So if you have any questions, let me know. Good luck.